Hi, everybody. Thank you for joining me. So today I wanted to talk a little bit about, present a story about what exactly happened last year when there was a request that came from a marketing team that landed on our team like hot potato. We basically had 3 weeks, somebody, how it happens in other business teams, somebody said, wouldn't it be nice if we could do this for this thing that was already planned, the dates are already set. And so we had to kind of scramble how to create these models and deploy them in 3 weeks. We do have a lot of ML infrastructure baked into our system, so it wasn't that difficult, but I thought it would still make an interesting story. So before I talk a little bit about the model, let me introduce what my company does. I work for a company called Sentosa, which is based in Washington, D.C. and London. We have 2 different offices, large customer base, both in US and Europe. Those are household brands. We build what we ourselves called a marketing AI platform that is really meant to help people understand how people are behaving on their websites and other user interaction kind of systems, and be able to build more AI-based models on top of that. And we run on pretty much all the cloud environments. We fit natively in people's own big data ecosystem. It's not like a SaaS tool. At a numbers level, the amount of data that we typically have, we work with hundreds of different behavioral sources. We built somewhere, we have at any given point somewhere from 50 to 100 models that are live in production at any time. In general, we analyze about 1 billion people's billion unique people's activity online, emails, and other kinds of systems. Typically, we're looking at like 30 billion or so interactions that we process through our system. So far, we've served billions of predictions across all of our activity as well. So a lot of people ask us this question: why is behavioral data important? Why should you really care about it? And so I'm going to explain the data the way a typical data engineering team sees. Imagine that you're a company, any company. Generally, what happens is you have a face for your customers, which is a mobile app, a website, you have an email system, people are going to call you. Those are like first level of your interaction information that you have for a particular customer, visitor. And then the next step is when your company internally starts understanding all of your customers' data and start sorting that out into different systems like CRM system, ERP system, financials. What typically happens is when you're looking at any sort of big data projects, people are generally starting with the data that they see in the inner circle. The external circle is generally sitting in a SaaS tool. Maybe somebody's using Google Analytics, somebody's using Adobe Analytics. These systems are tracking a lot of your interaction level data. If you're using any kind of email analytics tool or email tool to send emails out, those systems actually have tracking of when did the email get sent out, was it opened, yes, no, who was the person that opened it. There's a lot of information like that. What we do is we kind of allow bringing in this first level interaction data at the rawest level in somebody's own environment, and then we start doing more modeling on top of that. And a lot of times people, when they look at it, the first thing they ask is, why should I really care about it? I can do, what can I do with it? The thing is that data is really rich, and that data can facilitate a lot of different kinds of analysis. We've used it for media optimization. We've used it to do recommendations of many different kinds, of identifying fraud, of being able to identify who is more likely to churn. Like overall, that data is really rich. It's just messy and voluminous. So let me give a little more background on what we had to do for the Christmas project. We had a customer who wanted to be able to support, or they wanted to run a marketing campaign where they wanted to be able to discount a certain, let's say, products before they were going to be turned over by new products, and they wanted to be able to advertise, identify the people to whom they can actually advertise more effectively. And that using all the activity that was happening on their website. So from a background point of view, this was actually one of our smaller customer, not that much activity. There were around 2 million visitors a day. They had about 100,000 products, which meant that the product catalog was not like, even if they wanted to just go sell 9 products, it wasn't like every single product, it was just a few specific products from overall their catalog of 100,000 products. And when it comes to the point of interest that they were really interested in, the number of people that actually converted was less than 0.1%. And it is 0.1 percentage. It's not like 0.1 and then you do 100 on top of it. This is like, truly, truly class imbalance kind of problem. And so, so when we started looking through the visitor journey, like imagine that the big circles kind of telling us the people who visited the website, and then the first step was just from an analysis point of view, identifying people who visited any product, not just those specific products, but any product. That was like, much smaller. And then within that, we had a sliver of people that actually converted. So, so our ask was to build a model that was going to help us identify those people. There was also some existing stuff that was in place that was running from their marketing team. First of all, they were running some sort of a rules-based campaign. So this is like marketing team. They've already put some rules that anybody who visited this product page, we want to go show them certain activity or we want to advertise to those people. They were also using a, let's just say ad tech or marketing tech solutions have a lot of AI model, so they were also using those already, and they wanted to see if basically a model that was sort of custom made for those specific products was going to perform better or not. So that's essentially what we built. Now, the first thing that happens when we're looking at the behavioral data, there's a few challenges that we really run into. One is, generally speaking, the volume of data is very high. Like 2 million visitors may not look a lot, but at a person level, if let's say every person looks at 5 pages, that's 10 pages, 10 million pages or 10 million hits. If you're looking at activity history, you're looking at like, let's say 7-day activity history, 30-day activity history. You're looking at larger number of data points that you have to analyze before you can do anything. On top of that, the data is inherently complex because we're looking at website activity. So they were on page 1, there was this form element that was shown, another form element that was shown, they clicked on a particular link. It's really messy, and it also changes constantly. Websites change all the time. On top of that, the data is generally non-stationary. Like, you never have guarantee that people behaved a certain way today and they will continue behaving the next day or next week. So that is also a little more challenging to really work with. We also have, generally speaking, when we have data that is so messy, the first question is, how do you featureize this? How do you actually come up with features that work for identifying the right kind of signal? And because of the low conversion rates that we typically see, if we were to sample data before we even get started, that's just going to basically take away everybody that converted. We'd have absolutely no signals. So at least the initial phase, we cannot sample. We have to take everybody. Then put all the other challenges that come from the modeling perspective, that even if you built a model, you do have to make sure that you have some modicum of confidence that once the model has been built, it's going to be productionized, and it will work just fine. And the last thing that a lot of times people don't think about is you may have a good model, and that may work as soon as you put it in production, but over time that may change. And how do you really stay on top of your models? All of these things are not easy, but once you put models in production and they become mission critical, they become really important to resolve. So the first thing that we do in terms of doing our model analysis, or even in our data preparation, is we because our problem typically boils down to saying, let me look at past behavior to predict the future, in our framework, we've ended up deciding on this thing called the time-based window. So we are always asking a question from our system that, tell me what happened in the last X number of days, and let me predict in future. And so now we can completely convert our data preparation step by just defining the window, how far back we want to go or how much forward we want to predict for. Once we finalize that as a concept and we bake it into everything else that we do within the framework, then it was easy for us to kind of build our feature store. The feature store that we started building the features at the visitor level, so at the browser visitor level. And we started with a simple feature preparation. We looked at anybody's last 7 days of activity history. We looked at what kind of interactions they had. Perhaps some kind of pages, some kind of products, not just some specific products, but across the board. What kind of cart interactions they had. There's also, across the entire website, there were a lot of different form elements, some videos, some reviews, things like that people typically look at in their buying journey. So all of those things were included in our feature analysis. And then from that, we actually created a few different kinds of features, whether the feature was present, yes or no, because typically these features are very sparse. So just having one representation of whether the feature is present, yes or no, and the other is how many times that happen. And then we have some ways of, like some code that we've already prepared that allows us to start from that point and systematically scan all the different features, identify the features that are important, weight them to be sort of more important, ignore the others, and that's how, and at that point we start doing our modeling activity. So with this approach, we basically had started with about 1,000 features. We reduced it down to about 400 or so odd features. And the experiment setup that we had, this is again, it's like standard stuff that you do in a modeling world. You'd go say, okay, I'm going to start preparing my training data set. Now, because time for us is a first-class citizen when we're doing any kind of analysis, we go in and always ask, what time am I looking at when I'm doing my feature preparation? So we decided that November was the time period that we were going to do for our training data preparation, which again is constantly doing a look back and look ahead. So for all of November, we had a sliding window where we basically have every user's last 7-day history and then whether that user purchase something in the next 7 days or not. The other thing that we do, because this is again in an online behavior world, people's behavior changes constantly. Just because you had a model that worked well for one time period doesn't work in the next one. It is important for us that we know that our model work not just for one time period, but for a different time period. So we also always create one other data set that is for the next, like, a certain other future time period. So what we did was, by the time we did everything, this was like the first 10 days of December were done. So we were actually able to take a little period of December to do additional evaluation. So now we had 2 evaluation sets, one that was randomly taken from November and one that was all of December. And because there was a high level of class imbalance, we decided to use F1 score as our metric. And that works well from a statistical point of view. But when it comes to discussing the results with the business team, it's like they don't really understand that. They want to be able to understand, what does it mean from my business point of view? Also, because we have done these kind of models in the past, we know that if we were to build a model and make it so accurate that we have tuned our threshold to a certain point, and we tell them these 100 people have a 99% accuracy, they probably don't care about it, because at that point the sample size is so small they can hardly do any kind of A/B testing from a marketing point of view. So what we do instead is we actually we've gone back to some concepts that were very prevalent in marketing industry before, which is doing some sort of a lift projection, where we can explain that instead of randomly choosing a person and them having a chance of conversion to be, let's say, 0.1%, if we give you a group of, let's say, 1,000 people, what is the chance of them converting, and how much likely they are compared to just a random sample. So, at that point now we can discuss with business that overall, if we were to give you 5% of the overall population, what will be the lift number? What can you expect? These people may be 5 times more likely to make a purchase than your random population. That's a concept that business teams understand fairly well, and then they can utilize that to tune their marketing campaigns in a much nicer way. So once we, overall, in terms of how the process can be accelerated, the next thing that we really focus on is we start with a template of an end-to-end model that was already kind of envisioned. Like, what do you really need? Whenever somebody's building a model, there's few different things that people always have to do. They have to do their data preparation, they have to featureize their data, they have to build a model, they have to evaluate from a statistical point of view and from a business point of view. And if we know that these are all the things that will need to be done, if you start with a templatized approach of a pipeline, you're kind of filling in the blanks along the way. And a nice thing about that is when we start with a template, and because we're filling things in, it forces us to ask the question. Maybe the data scientist is not really thinking how the business impact is going to be measured, but they're forced to kind of answer that question. If they don't know that, they're going to liaise with the business person to get that answer figured out. The other thing it does is it takes away a lot of other boilerplate code away. They just have to go plug in certain components. It's very similar to some of the declarative frameworks that I've heard in many other talks that happened today. And the last thing, which I think is the most important one, is when we start with a template like that, we don't really go and start building a very complex model. The first step we do is we take perhaps just one feature or something really simple, just take 1 day of data, and make the entire pipeline work end to end to the point that we know how that data is going to be produced and how that's going to be pushed out to the other system. Once we have done that, now because I have 1 day, it's very easy for me to now focus on my experimentation part and add more features, add more days of data, and because I've set up everything, I am starting to log my model results, and I can just keep on keeping an eye, just like MLflow does, the framework that we have already also starts doing, does the same thing. So it's very easy for us to go and see all the 20 different experiments that we had run to be able to say, okay, this was my best model, this was my best experiment, and I think I'm happy with it. Everything's cooked up. All I need to do is at this point just deploy this and set it up on a schedule, or if this is in an online serving world, then I just need to make a few more tweaks and it's going to work just fine. The other thing that we also do, with the other thing that we also do in this case is when I was showing the previous diagram, there's all of these nodes that you see in this DAG. Now, the thing is, these DAGs themselves are abstracting away some sort of a design pattern. So like I said earlier, that time is like a first-class citizen. Now, what happens is, let's say the first point that I have in the DAG there, it's asking the user in some ways that, how many days do you want to go back? And think of this as a code that has already been prepared that's taking some parameters, and it's letting the end user define that I want to go back 7 days. I want to consider these pages. I want to consider these elements, form elements. And now what happens is, once we start going towards an approach like this, anytime I want to write random code, I can start with random code, but over time, whatever is repeatable becomes easy to abstract away in a process of its own. And anytime you don't like it, or there's some optimizations that we found, what was presented today earlier, the filtered joints and what was out there in the keynote today, we discovered those things a few years back, and we embedded that in our code one time, and then from that point onwards, we don't really have to worry about redoing the same thing again and again. The same thing happens with every kind of component that we're adding in there. It also makes it easy. This happens to us, and I'm sure it happens to other companies too, that there are some people on the team that are very well versed with Spark, some people that are more familiar with other tools, not as much with Spark, but it gives them an approach where they can start building and doing data science instead of just trying to learn how to write very low-level Spark code at some point. So this is a question that we get a lot, which is why did we use this process or this node as an abstraction concept? And actually, that is, in a way, a functional programming concept. It's called Functors. I don't know if you've heard of that. But I also heard the same concept earlier today where, it's similar to declarative programming, where what we're saying is, go give me activity of a user from last 7 days, and I want statistics on all of these activities. I'm not going to tell you how to do it. I'm just telling you I want these. And then that code already is optimized to the right level that it can go grab all of that information and prepare the data for you. And the reason why we had to do it as a process instead of using any kind of Spark concepts was that a UDF, UDAF doesn't exactly work. UDAF, you kind of have to provide your group by and all of those things earlier, the way you're using it in your system. Also, the way the transformers work in Spark, it wasn't very easy. It wasn't very easy for us to just write random code and suddenly fit into a custom transformer and have it work. It also makes it easy for team members who are not always familiar with every single thing about Spark. So they don't have to worry about it. It's like taken care of a few times and then it just works. And then the last thing, which I think is the most important, is there's a lot of stuff that goes into making sure that your code is reliable. When I'm saying, go back to last 7 days and grab me statistics for all of these, if we find 5 people and ask them to write that code, all 5 of them are going to do things slightly differently. also, they're also going to probably have one or two things that are slightly different. And so it's never really exactly the same thing that everybody's following. Now, if we look at this as a process, we can actually put some test data, put a expected data set on the other side, and now we can say, okay, we've already tested this. This works exactly the way we've wanted it. Now let's put it on any kind of production data, and we know that it's going to work just fine. So there was a tangent on why we do things a certain way. Now going back to the experiment. So when we ran our experiment, the first step we thought was, okay, we're looking at like 9 different products that we want to push in the market. Let's build a multi-class model that's going to make things a lot easier for us. And it didn't really, unfortunately, that didn't pan out because there was such a big class imbalance that the model was just not able to pick anything. So we thought, okay, let's just give it a try, see if we can build a binary model, and if that ends up giving us something, at least somewhat of a signal, which we did. That was fairly promising. So then we started switching over a whole bunch of our algorithms to see how that was working. The first model that we had was random forest. That gave us a decent learning metrics and evaluation on like a site split. But what we found was that model, when it was taken from November to December data, applied to December data, it wasn't performing as well. And this wasn't the first time we had observed this. A lot of times we have seen GBM, random forest, they work fairly well when you're looking at your test versus train split. But as soon as we start taking that and applying to a completely different time period, we generally find that they might have overfit and now they're not applicable to the new time period. So then we looked at logistic regression, which has worked like, this is not AI at that, none of this is really AI, it's like a simple model. Logistic regression was okay. It wasn't as good, like it was marginally lower than random forest from a learning point of view. But it ended up giving us a good lift at the end, and it performed better in December as well. I think I'm running out of time, so I'm going to speed up. The last thing we had to do was when we productionized this model, we had to put everything together. I'll just go back to the last. We put everything together, and then we have an integration that talks to the ad network that just pushes out all of the predictions. And I actually have the results of how this actually panned out in the market. So what happened was, so the dark green is the impressions that were from the rules that somebody had manually added, some marketer had done. The blue one is this AI models that, from ad tech components. And the light green is the one that we had built. So it turns out that our models were not that great at getting a lot of impressions because it was already a very crowded marketing activity. But we did get a lot of conversions in the end. So overall, because it was perhaps a little more relevant than whatever other people were doing, the click-through rate of those campaigns was much higher. And the final conversions that we got out of that was also much higher than all of the other modeling techniques that that company was already using. And that actually concludes my presentation.
Thank you. So we have a few minutes for questions. Please raise your hands.
Thank you for your talk. I have a question. How much traffic did you handle with these models, and whether you had also a comparison on the workload levels, how much traffic you need to cover with the cluster to handle it easily?
Can you repeat your first question?
How much requests you got, and how you were handling the workloads on the servers?
How much request in terms of the prediction requests.
Yes.
So because this was more of generating predictions and sending it to the ad tech industry, we were not in this case serving it in an API manner. Instead, what we had to do was we had to generate predictions and push it into their system.
Thank you.
Okay, I was just wondering how do you put to production the model that you found in experimentation?
So our platform already includes that component. So what we do is when we have built that end-to-end pipeline, because we have built it and we've tested it in this sandbox-like area, then at that point we know that pipeline is working, and then we can deploy it to production. So production is a separate area. It just takes care of that, and from there we set up jobs and we have it run.
I have two questions. First of all, did you implement time-based series in these predictions?
When you say time-based series, you mean time series like ARIMA modeling kind of thing?
It's like if I clicked a link today and yesterday, it's not the same thing.
Yes,
You know,
they will be
it's-
different. They are different features.
There are time spans between the clicks. Did you implement this in your predictions?
Yes, so as a feature,
Yeah.
no, we did not.
And how did you aggregate, let's say a certain user had 100 clicks, so you had to aggregate it to a feature. How did you do this?
So we aggregate it at the user level, and what we also do is the same user, let's say there was a user who was present today, and then that user comes back tomorrow, and then that user comes back the day later. For that user, we have 3 different training samples, one for day 1, for last 7 days, second for day 2, with last 7 days with respect to the second day, same thing with the third one. So in a way, we have the time span modeled in a certain way, but we're not really doing it exactly as the time difference between 2 different activities. Sorry, I think I'm not answering your entire question. What was the other part of your question?
It's like I asked if one user clicked 100 times or he visited
That is a
100
simple,
pages.
yeah, that's a simple, I mean, it's a group by at a visitor level, and then we're aggregating all the different elements separately. So if it is, so typically the way our data feed is, there's about 1,000 or 1,000 odd columns that we receive from, let's say, a web tracking system. So it's just a massive group by with a lot of different columns that we're combining.
Thank you.
I'm curious why you chose 7 days as your window.
We could have gone a little bit further as well. So we have used actually 7 days, 14 days, a slightly larger time period. What we've noticed is when you're looking at a very short-term advertising campaign that you're running, then it's a lot easier to only look at a shorter time period. If there was a longer-term component that was in it, then we also look at a larger time period. And to be honest, in most of the cases, we would look at different time periods to make sure that we have a better understanding of what the right choices were. Given that we had such a short time in which we had to turn this around, we were just happy that we actually got a good working model in place, and we were able to get everything working in time.
Cool, thanks.
Do we have any other questions? Yes.
Nice presentation, thank you. Do you have some blog post, or is it possible to see any of the functors or the actual abstracted code you wrote?
There's something that I wrote about look back and look ahead as a concept, but not about the abstraction of a process itself. But I can, if you think that would be something that would be useful.
Yeah, I'll get in touch later. So.
Okay.
Great.
Okay, let's put our hands together and thank Charmee for the talk.
Thank you.